This is a small short discussion about the signs of trigonometry in each one of the quadrants. And we're going to start off with the unit circle here. So these coordinates here are 1, 0 for 0 and 0, 1 for pi over 2. And over here at pi, the coordinate is negative 1, 0. And way down here is 0, negative 1 at 3 pi over 2. And then of course you come back around and you're at 2 pi. We still need the unit circle at least for these four coordinates because they're the only way of finding out like sine of pi over 2 or cosine of 3 pi over 2 or tangent of pi, things like that. But what I want to talk about is the angles in between each of these points in all of the quadrants. And we've dealt pretty much with just first quadrant coordinates and using these two special triangles. These are two you need to memorize. This is the 30, 60, 90 triangle, and the easiest way to remember it is the hypotenuse is always going to get 2, the shortest side is going to be half of that, and then you just have to remember that square root of 3 is the third side. And the easier one is the 44, 45, 45, 90 triangle. It's isosceles, so you'll have a 1, 1, and then again you have to memorize that the third side is square root of 2. Alright, so using these information and one more little piece that I have to get into, we're going to want to talk about the signs of each one of the trigs in each one of these quadrants. Well, if you're in the first quadrant, remember, now we're going to write it. If I'm dealing with sine of an angle, it's going to equal the y coordinate on a unit circle. Cosine of an angle is going to equal the x coordinate on a unit circle, and the tangent of theta is going to equal the ratio of y over x, as long as these coordinates are on a unit circle, nowhere else. So if I'm in the first quadrant, well, the x is positive, and so is the y coordinate if you're any point along the circle in the first quadrant. So all of the trig functions are positive in the first quadrant. In the second quadrant, we have y is positive, but x is negative. So the only one out of these three that's going to be positive is the sine. So I'll just put sine is positive in this quadrant. The other two are going to be negative because they have an x involved, and x's in that quadrant are negative. Alright, down here in the third quadrant, we have x's are negative, and we also have y's are negative. So the only one that's going to be positive is the one that has both of them, which would be the tangent. So tangent is positive in this quadrant, and the assumption is the other two are negative. One has a y, one has an x, and both x and y are negative there. Alright, in the fourth quadrant, the only thing that's positive is the x-axis, the y-axis is negative, so the only one that's going to be positive is this cosine. So cosine is positive in the fourth quadrant. The easy way to remember this is a little acronym, and it pretty much goes all students take calculus. So when I say students, I mean sine, and that's the only one that is positive. So if you have an angle in the second quadrant, the value of the sine of an angle is going to be positive, the value of a cosine is going to be negative, and the value of the tangent of an angle is going to be negative also. So that's what this comes in handy doing. So if we try to do a problem using a reference angle, that's what we're going to talk about here, we're still going to need that all students take calculus and the special triangles. For instance, this is the method of reference angle, and we want to evaluate exactly the cosine of 5 pi over 6. So this angle here, I drew it perfectly, is 5 pi over 6. The reference angle is always going to be the acute angle between the terminal side and the x-axis. It's never going to go towards the y-axis. Reference angles are always towards the x-axis. And the reference angle here for 5 pi over 6 is this measure in here. And this is only going to be pi over 6 to make the total, 6 pi over 6 or just pi. Alright, so the reference angle here is pi over 6. So what we can say is that the cosine of 5 pi over 6 is going to be the same as the cosine of pi over 6. And the only difference between these could be the sign of it. positive and or negative here. That's why I left a little gap. So this is where you come back to all students take calculus. The only function that is positive in the second quadrant is the sine function. So the relationship here is equal only if I make that a negative cosine. So cosine of pi over 6, 30 degrees, cosine is adjacent over hypotenuse, so that would be square root of 3 over 2. So that the solution here is negative square roots of 3 over 2. The cosine of 5 pi over 6 is equal to negative square roots of 3 over 2. And that's it.